Hello everyone, I am Hannah M. Daklas from BSECE 3A. And in this presentation, I will discuss to you my performance task number 3 for ECE 23. So before anything else, I want to discuss to you the modulation schemes. And modulation schemes refer to the technique by which the audio signals is encoded as modulated square wave. PWM is the most common technique. So fundamentally, there are four basic pulse modulation techniques. These are PAM, PWM, PPM, and PDM. So PAM, or pulse amplitude modulation, is based on the conversion of the signal into a series of amplitude modulated pulse. Next is PWM, or pulse width modulation. It performs sampling in time. The information is coded into the pulse time position within each switching interval. Next is the PPM. PPM, or pulse position modulation, the value of each instantaneous sample of a modulating wave is caused to vary the position in time of a pulse relative to its non-modulated time of occurrence. Next is PDM, or pulse density modulation. It's based on a unity pulse width, height, and a constant time of occurrence for the pulses within the period switching. The pulses within the switching period. So in this presentation, we will focus more on the pulse width modulation and NBDS. So pulse width modulation encodes the amplitude values of original signals in the pulse width of a square wave output. So as you can see here on my presentation, there is an analog signal and a square wave output. So the amplitude of the analog signal corresponds to the width of the square wave output. So there are four fundamental pulse modulation schemes. These are NADS, NBDS, NADD, and NBDD. So these four belongs to natural sampling, and NADS and NBDS are single-sided modulation, while NADD and NBDD are double-sided modulation. NADS and NADD are two levels, and NBDS and NBDD are three levels modulation. So now let's discuss more about NBDS. So before explaining more about NBDS, I want to define its characteristic. So as I said earlier, that NBDS belongs to natural sampling. So what is natural sampling? The sampling refers to the amplitude representation in the modulation, such that comparator sampling input signal through comparison with the carrier. In simple words, analog signals results in natural sampling. Next is single-sided. Single-sided modulation can be performed with ascending or descending sawtooth carriers. So now let's discuss about the operation of NBDS. So an example for NBDS for natural sampling is class BD switching. The use of a 4-device full bridge configuration permits the use of class BD. Depicted in this figure here, the driving method of achieving this 3-level modulation. The two devices on the left, the side marked A, are switched exactly as described for class AB. However, the devices on the right, marked BD, although still complementary to each other, are no longer the simple complement of the A side. Instead, the B devices are driven by a modulated driver derived from an inverted version of the audio signal. The effect of this is that the B side switching node waveform is inverted in time within the sampling period with respect to the A side waveform. So I will discuss more about the NBDS output waveform, its differential mode, and common mode. So as you can see here on this picture, there are two analog signals. So the first analog signal represent the A side. So if the analog signal is higher than the sawtooth carrier, it will result to 1. But if the sawtooth carrier is higher than the analog signal, it will represent the 0. It will result to 0, and the process will go on. So in B side, the same process. If the analog signal is higher than the sawtooth carrier, it will produce a 1. And if it is lower than the sawtooth carrier, it will produce 0. So the differential mode represents the difference of A side and B side. So here, 1 minus 1 equals 0. Here, this part, 1 minus 0 is 1. So the process will go on. Okay? So in the common mode, it is the average of A side and B side. So here, the average of 1 and 1 is 1. This part is 1 and 0. Their average is 0.5. Next is 0 and 0, and their average is 0. And the process will go on also. So in class BD, since the two legs of the H bridge do not exactly complement each other, the signal across the load, which is developed by the voltage at the A switching node minus the voltage at the B switching node, does not simply switch between the two supplies. Instead, there is a third state, the zero differential voltage, established when both switching nodes are at the same potential, which is never possible in class AB. One immediate effect of this is that the class BD has a significant common mode component, while class AD exhibits no common mode voltage. Class BD also requires more precise switching control and can introduce added complexity compared to class AD. So despite of the disadvantages said in the previous slide, performance of the class BD is generally considered superior to class AD. The main advantage of class BD involves the high-frequency switching components. In particular, for low and idle input signals, the output contains very little high-frequency energy. So in summary, modulation schemes refer to the technique by which the audio signal is encoded as modulated square wave. Also, there are 4 modulation techniques such as PAM, PWM, PPM, and PDM. PWM encodes the amplitude values of the original signals in the pulse width of a square wave output. Lastly, the main advantage of class BD involves the high-frequency switching components. So here are my references, and thank you for watching.